Hi everyone, here is a quick short demo of my recent project. In this project, I made use of Python and Power BI in visualizing Lagos State rooftop solar potential. This project basically provides insights for stakeholders, policymakers, businesses in the renewable energy sector in making data-driven decisions for promoting solar energy adoption. I got the data sets for this analysis from energydata.info. The dataset is quite huge, about 1.5 million entries. I cleaned the dataset using Python and I dropped some of the unuseful columns that are not that useful for this analysis. Columns like object ID, UID, city, units, installation price, and the likes. Then also the data set consists of about 16 duplicated value, so I dropped that. Then I looked into some of the features in the data set. There I found out some inconsistencies. For instance, the local government area feature, I found out that this particular entry, Ogun, it's another state. It's not a local government in Lagos State. So I have to drop those values, those entries. So from there, I also check another feature, solar panels. There I found out that about 1.4 million places or areas in Lagos State had no solar panel, had no rooftop solar panel. Then about 12,000 of them had rooftop solar panel installed in their buildings. So, but this analysis is majorly focusing on those places, those areas that don't have a solar panel. So for that, I dropped this second, those entries with years. So from there, I look into the missing values, and there I found out that there are some features that have much missing value in them, like estimated building height and also the estimated capacity factor. So normalizing this, I found out that for the estimated capacity factor, the missing value is not up to 1% of our data set, while for the estimated building height, about 14% of it, as in 14% of the data were missing. So for that, for the estimated capacity factor that is not up to 1%, I dropped it, while for the 14%, as in for the estimated building height, I have to do some imputation for that. But firstly, before inputting, I visualize the data set at the feature, I mean the building heights distribution, and I found out that the distribution is right skewed, with most building heights between 3 to 4 meters, about almost 70 or 700,000 of that of such. So from there, I look into some of the building type that constitutes to the estimated building height. There I found out that single family residential building type has the most values, about 1.2 million plus. However, I went further by looking into the distribution for each building type, looking into their height. For instance, single family residential, the range 3 to 5 meters are most common compared to industries in which they have high as in high buildings, like about 40 meters, 40 plus meters. So for this, I inputted the median for each category. For that, I grouped my datasets by the building type and find the median for each subcategory. I mean for each building type subcategory, then I fill in the median for each of them. And from there, I recheck the dataset and found out that my dataset is clean. Then I save that. Alright, let's move to the visualization part. I used Power BI for my data visualization, and I used some visuals like map. I used columns and bars and some slicers and some KPIs cards and the likes. For the map, I utilized GeoJSON file which I got from a website over here, HDX here. In this website, you can find Nigeria local government's JSON file over there, which you can use for your map. So I downloaded this data, data sets, and I converted it to GeoJSON file for my visualization, because Power BI can only see files like GeoJSON and the likes, but for JSON file, it's not compatible with that. So I converted it using geojson.io. So you can simply just come here and upload the file, the downloaded file there, and convert it and save it as GeoJSON. So after that, here are some of the KPIs that I used. Let me reset that. Okay. Lagos State basically had about an average annual power of 4.94 gigawatts. That is, about 4.9 gigawatts can be generated only from solar panels, as an installation of solar panel renewable energy, and that will take about 177.74 kilometers square area. That's the, as in the space that will be taken by those solar panels. Then the peak installable capacity, the total peak, as in the highest, the highest peak installable capacity is about 9.84 megawatt peak. So let's visualize a local government in Lagos State and see what we have over there. Let's take, for instance, let's see Alimashaw local government. Alright, in Alimashaw local government, we can generate about an average annual power through solar, as in solar energy, of 877.14 megawatts, and the panel will be installed on rooftop of about 31.86 kilometers square, and the peak installable capacity that can be gotten from the installation is about 2.20 megawatt peak. Then coming down to the average energy potential by the rooftop, we found out that the quality of the rooftops differs. There are some rooftop that are good enough, those ones are high, while there are some, the quality are medium, while there are some that the quality are low. For those high quality tops in Alimashaw local government, we can generate about 38.16 megawatts hour energy potential from the cumulative rooftops. Likewise, for those medium type, we can generate about 38.08 megawatts hour. All these values are annual average values that we can, as an annual average power value that we can generate from all those places. Likewise, I found out that the energy generated also depends, also correlates with the tilt angle of the roof. That is how bent the rooftop is. If the rooftop is between the range of 0 to 10 degree bent, it has more higher power, as in energy potential. Take for instance like this Alimashaw local government. For those rooftop of about 0 to 10 degree, the energy potential is like 28.22 megawatt hour, while those of 21 to 30 degree also have an higher energy potential. Then coming to several buildings in Alimashaw, like the commercial buildings, hotels, industrial building, multifamily building, public places, health places, schools and the likes, we found out that industrial places in Alimashaw had the highest potential energy potential of about 117.61 megawatt hour, meaning for a stakeholder that wish to invest or that wish to promote energy adoption, so as in solar energy adoption in Alimasho local government, could look into industrial places by installing solar panels in some of the industrial places in Alimasho local government. Likewise, we can also take a look on other places over, as in Lagos State, also like Apapa, Agege, and the likes. Let me reset that. So, for this project, as I said earlier, focuses on renewable energy, which solar energy is one of them. For any stakeholder or any businesses that wish to make a data-driven decision, can simply use this as a guide or as a starter for their projects. The documents, as in the notebook, the visuals, and also the GeoJSON file, are all below this video link. You can go through it, and your feedback is very key to my analysis. I expect that from you. Thank you so much for viewing this. Thank you so much.